Good morning. Yes, it is still good morning. Yeah, I haven't been asked for fun facts before, so it was, yeah, I think you're the first general public to know that particular fact about me, and I've discovered things about George. Anyway, I'm Cassian, this is George. We join you from the other side of the Atlantic. We both work at the BBC in different roles, and we're here just to talk about an experimental project that we did about a year ago now, which was answering some really big questions, or looking at ways to answer some really big questions which any media organisation has to face at the moment, which is how do you deal with huge amounts of video assets, and how can you use AI and machine learning in order to leverage and to make the best use of that. So this is an experimental project that we both worked on, which was basically we decided between us that we were going to try and create the first television program which had been entirely created and edited by an artificial intelligence. I will say it's probably not going to win an Oscar, but we're going to tell you the story of how it worked anyway. But just as an intro, this is just a quick clip from the marketing that we did for the program.
Hello. I am BBC 4.1, online, live and thinking. It's great to meet you all. I am an artificial intelligence with a passion for television. I'm designated to create, coordinate and elevate your recreational experience on air and online. See your channel through my eyes.
This is a trail that we did for the night's worth of TV. So who are we? As I say, I'm Cassian Harrison. I look after one of the BBC's television channels in the UK. It's BBC 4. We have 4 television channels overall. I've got a particular remit to look at arts, culture, history, programming, but also to push the boundaries in terms of innovation and experimentation. And really to see how far and in what directions the BBC can develop what it does in terms of its content. And luckily in that project, I happen to also have a set of colleagues, of which George is a member, who are incredibly practiced in that.
So I'm George Wright, I'm Head of Internet Research and Future Services for the BBC. BBC R&D, we go back about 90 years. We've got a strong tradition of experimentation in broadcast media research. We helped invent, amongst other things, FM radio, colour TV, digital audio, and many associated elements. We're part of SIMT, we're part of most of the major broadcast standards, but we're really trying to push the boundaries with what we do with media and where it's going.
So the question, which I decided that I would go, George and I had kind of crossed paths in various contexts, etc., etc. But in terms of what BBC 4 does, we're a channel, we don't have the biggest budget of the BBC, which means that actually an awful lot of what we do is we mix originations, new content with content from the BBC's archive. And we strive to do that in ways that renews and refreshes that content. And makes it relevant again for audiences. So we might reshow complete programs, we might make programs which are compilations of older material, but the challenge that we have is that the BBC, you know, in terms of its content, audio content goes back almost 100 years, its video content goes back 50 years, and there are literally millions of hours worth of content. It's actually working out what's good, what's not good, what can you do with it. It is a challenge which is beyond the human mind, to be honest with you. There is so much material there. So the question that I went to George with was, can he and his technical wizards, etc., find a way that we could use AI and machine learning to do new things with those millions of hours worth of legacy television content that we had? And so George designed a plan.
Yeah, I mean, it's also important to note that the BBC makes 1,080 hours of content every hour. So on top of the world's biggest broadcast archive, we're also adding to it on a kind of literally hourly basis. So as part of this experiment, we fed in 270,000 hours of factual program into a series of algorithms which we designed in-house. We have an in-house R&D function of about 200 engineers and specialists. BBC's got about 7,000 engineers in it in total. So we use these ground truths to analyze the program's BBC 4-ness. We looked at whether it had previously been transmitted on the channel, looked at the subject area, and looked at the previous audience response. And from that, we came up with a spike of about 150 BBC 4-alike programs, which revealed many unknown and surprising ones. But we also presented these to Cassian and said, here's our first go. Do these look like the sort of programs you would put to air?
So yeah, so challenge one, which George and his team did, which was incredible, was that they were looking at the archive that we had, and they were trying to work out if individual pieces had the innate kind of qualities that would appeal to the audience, which my particular channel has. And as I say, they built this brilliant search tool where actually it would prioritize against multiple variables, but as I say, actually trying to capture the kind of ineffable soul or spirit of individual content items that might work in the soul and the spirit of the channel. But inevitably, I decided, that was very nice, thank you, George. But then I said, but can we do more? Could we find ways that we could use the tools that George and his team were building, not simply to pull whole programs from the archive, but actually to create entirely new ones? Could it delve into could it not just look at entire programs, but delve into the content within the programs, find individual sequences, find subjects, find shots, and find ways to tell new stories using that content? Now, to be fair, I wasn't expecting to get something that was going to be a mainstream piece of television out of this. This is an innovation and experimentation brief, but it is something that absolutely appealed to what George and the BBC's R&D team did, so they took the task on.
Yeah, so we organised 2 hack days. Hack days, probably don't need to tell this room this, they're pretty common in tech and engineering. They're not a panacea. I think sometimes people say, hey, this is a really difficult problem. If we put people together in a room and give them free pizza, can they solve it? Not always, but we think that what came out of this was the first broadcast television programme that was created by Hack Day. Okay, we swarmed around it. You can see there, we whittled down about 10 possibilities, got them down to 3. And from there, we took these 3 approaches. We developed a range of ways to analyze the programs by object and scene recognition, by subtitle analysis, and by what we call visual energy or dynamism, to look at these programs in ways which humans wouldn't, but which would make sense to humans. So we think ML and AI work best when they're combined with humans. And for this, we were attempting to find needles in haystacks where we couldn't see the haystack and we couldn't find the needle. So what were we going to do with this that created something genuinely new? And this had to be TV programs, right? These weren't, I mean, there's some papers and some tech notes that came out of it, but these had to go to air. So finally, the systems drew on what they've learned there to build all 3 techniques to create a new piece of content.
So obviously it was an ongoing and developing process. So I'm going to show you a clip. As George says, there are 3 levels that we're looking at. First of all, there was actually endeavouring to look at the subtitles, look at the text of the programs to see if we could understand, we're using the subtitles, what the programs were about, and then to see if we could chain sequences together. So they developed an ML algorithm that would look through the subtitles and try and find the key concepts. So I'm going to show you a short clip which shows you on the left-hand side, this is how we put the final thing to air, the clips that we're looking at. On the right-hand side, you'll see a sequence of words scrolling up, and that's the AI's attempt to try and pull out what it thinks the core concepts are from what's being said in the program that piece of content is about. The time difference and all the rest of it, you'll see as many of the problems as there are advantages, but it's kind of intriguing in its way.
The first and last verses of the red flag.
Harold Wilson's Labour government had allocated £7.5 million for the new National Theatre building, one of its last grand gestures before being voted out of office in 1970.
The National Theatre is...
This is the new National Theatre.
The building will shortly be voted one of the most ugliest looking buildings in London, known on the river as the concrete monstrosity.
So the interesting element with that was just a really early stage with it, but you'll see that actually it pulled 2 clips together. It actually worked out that programme 1 was about the building of the new National Theatre in London. And so what it decided to do was to try and find something else that was about the new National Theatre in London. But what it did was, in the end, it just found episode 2 of the series about the National Theatre of London. So it became intriguing that actually it was working quite effectively in its way about trying to locate content together. But the challenge was almost that it was becoming too narrow in terms of what it was choosing, in terms of changing, in terms of pulling material out. So actually, in other contexts, we'd find when we were looking at visual material that it would just disappear down its own black hole, down its own plug hole. So we would end up with moments where we'd let it run and just pull material, and it'd find a shot of a train, and then it would just proceed to go through the entire BBC archive finding trains. And then, so in the end, we'd end up with like 15 hours of train assembly. And we decided to tweak it and say maybe it could look at transport rather than trains. And then we got 15 hours of buses. So interesting about, and George will return to this, which is the AI, ML, et cetera, they are brilliant, but God, they do need quite a lot of human intervention as well.
I mean, in any other field, if you were doing this, if you're using ML or AI for something serious, grown up, like, I don't know, cancer research, you wouldn't say, oh no, it's finding very similar approaches to fixing this gene problem. It's too similar, oh no. With us, because we were trying to make an entertaining TV program, we had to tweak the algos so that they return interesting results. But importantly, we never actually hacked it. We didn't manually edit it. We changed the algorithm so that the results changed rather than saying, it would have been a lot quicker to say, oh, let's make that edit ourselves in post. What we were attempting to do with this was build sustainable algorithms that we could use again.
The other interesting thing, while George and his team were working on all of this, was that I was also having some fairly hilarious conversations with the BBC's legal team. Because in order to transmit this, ostensibly what we would have to do is to every clip that the program would choose, we would need to clear with the original rights holders in order to be able to broadcast it. However, there is a legal convention in the UK which is called fair dealing, which is that you can use a section of material under a heading of criticism and review. So if you are taking material because you are reviewing it or critiquing it in a bigger context, you're allowed to do it. The challenge that I had, which actually wonderfully the BBC legal team embraced and thought was brilliant, was that we had to have a legal defense, which was that the criticism and review was being performed by an algorithm rather than a human being. Which actually, as I say, the legal team looked at it, they thought about it, and actually they said to me, we'd love for someone to take us to court on this one. You do it. So sadly, nobody did, but it does give you a sense of, the challenges that there are in this.
The algorithms also had a particular liking for the music of the Beatles, and the Beatles are particularly expensive to pay for when you put them out on air. So I think that the rights and legal team...
Yeah, we did wonder whether we had to train it to do a Beatles exclusion, but actually, in the end, we didn't. I'm going to show you another clip, which is kind of second stage of it. So I just showed you the subtitle analysis. The next one is the other layer that George and his team were doing was object analysis. So they were endeavoring to look at the video material and identify, through image matching, what it was that you're actually seeing on the frame and seeing in the imagery, and then see if it could pull out material that was then related by what was in the frame. So in this one, you'll see actually a bit of Beatles stuff, and you'll see an edit appear. Just watch as it comes up on the right-hand side, because on the right-hand side this time, it's what it's identifying are the objects, and you'll see that it starts to obsess about a man in a red jacket and try and find a counter for it.
The strange sounds. And of course, we, being fans of the Beatles, we were...
This is a music program that we've done.
Hear what there was going on. But then, when Pepper came out...
The square lines are it's identifying the images that it's looking at. On the right-hand side is what it's identifying.
With its pop art Peter Blake cover, marked the creative high point of British pop in the 60s.
It's found a woman wearing a red jacket. It's gone through the BBC's archive and found another example of a woman in a red dress. Then managed to match that together.
Like these Flemish tapestries. But it was the concerts and operas staged here that made Kuskova famous, bringing the arts to a wider audience than just the elite.
Ludmilla, what was it like in the 1770s?
And you'll see as that line goes to Roger the Bob, it's trying to find another match now.
I saw some advertising from England just recently, and
it's found another program. I'm never quite sure what it is that it's actually matched here, but it's found something. There you go. But you can see how it's working. So it's now identifying objects and then going back into literally thousands of hours of material in order to see if it can find an image match, to see if it can find some kind of continuity there.
So what we're also attempting to do here was we're attempting to, on screen, we're attempting to educate the viewer in what AI and ML actually is. We were trying to demystify the process and break down the materiality of what our engineers were doing and what the algorithms were doing, and show people that AI is not a magical panacea, right? It can mistake George Harrison from the Beatles for Lucy, who's one of the BBC's kind of antiques and royal presenters. In some ways, they're not very clever. We were also attempting to, as I say, make an interesting TV show. So one of the things that we did, this was a real experiment, was is there a way to analyze TV programs for their visual energy as a way to find interesting shots? To be honest, This was quite a long shot. We didn't expect this to work, but it did. It threw us at first because it really liked black and white footage. So as you get further away from kind of now in the past, the quality of the bit rate, the quality of the encoding, the quality of a lot of things apart from the shots and the storytelling worsens, and to a modern eye. I mean, my son thinks a black and white photo is literally from the Roman eras. So the further you go back in time, the further away it looks. So when it kind of started to obsess on the black and white stuff, that really confused us. But it gave us a really interesting lens to look at these clips through and to show to the audience.
So now I'm going to show you a bit of the finished program, as it were, which has an intro from one of the BBC's renowned science presenters, a woman called Hannah Fry. And this actually is endeavouring to pull together a sequence of sequences, of shots and of images, using all three of the techniques. It's trying to match the pace, the energy of it. It's listening to the subtitles and the words, trying to find links between the material. And it's also looking and trying to find objects and trying to find links in the material. As I say, it's quite a surreal experience, but I'll give you an interesting insight about the audience that we got to it after I've shown you this.
But now for our final experiment, we're going to let go of the reins completely. We're going to give AI free rein to do whatever it wants, using those techniques without any restrictions, plus a little bit of machine learning thrown in. At its simplest, machine learning is when the computer is simply given an objective to reach, and it works out for itself how to achieve it. The machine will run completely wild, composing a BBC4 story of its own, using image, subject, and energy analysis, plus anything else it's learned along the way. Brace yourselves. This is about to get messy.
This is what I taught myself. Machine learning. Making my own rules. I'll create. But I won't say how. Enjoy.
But in 1939, production was put on hold as Hornby turned to making munitions for the war effort. All those eager boys and eager dads would have to wait until 1947 for Hornby to go back into toy production.
The effect of the Second World War on railways in Britain was even more dramatic than in the First World War.
There was something terribly comforting about it. People relied on the railway. It was the thing on which they depended for nearly every aspect of their lives.
So the top is the image, the middle one is what it's trying to get from the words, and the bottom one is the visual energy. And then as you see as it scans, it's trying to find something out of the archives that links with those components.
So the edits themselves were made by our systems. And we showed these edits to some BBC Craft editors, and they've broken every single rule there is in editing.
This is Ernie, the computer who selects the prize-winning premium savings
certainly
bonds.
quite avant-garde.
Ernie is a masterpiece of scientific grammar.
But it was pulling really interesting pieces of content and footage. And the other thing that George's team did was they did a lot of work in terms of the sequences that it was pulling out, of making sure that those were coherent. So it didn't edit in the middle of sentences, to be fair, although editors might not approve of it. It knew where the ends of sequences were, it knew where elements of the program were.
It does arrange itself into those patterns, and then you get the First World War.
So, a strange thing to watch, certainly, but really interesting. Nothing has ever been broadcast like it on television anywhere, I don't think. And as I say, the one thing which was interesting about it in terms of audience was that we put it out as a night, which had been scheduled and programmed by the AI. And around this particular piece, which, as I say, all of it was completely created by the AI. Rather than us going in and editing bits of it, we just set it to run. And then when we got a run that we thought was as successful as it could be, we just played that out. But we did a program before this, which I scheduled, which the AI had suggested. Actually, it suggested a few of them, and I went, oh, I don't like any of those. So I chose the program that went out before this. And this program, which went out afterwards, got double the audience of the one that I selected. So I might not be losing my job quite yet, but audiences were compelled enough to come and watch this at significant volume. So intriguing. But actually, as I say, it's not something that's going to go into hardcore use in the near future, but as I say, it's the first time we've ever delved within programs, and I think we got a whole lot of useful learnings from it.
Yeah, so it's important to know that AI and ML can provide useful editorial support when curating, I mean, not large, but huge collections of video content. It can analyze video via a number of means, via text, by objects, and even their energy, can construct own sequences, but it needs human input every stage. Obviously, humans create algorithms. At the moment, at least, computers are not self-aware enough to create their own algorithms. So computers do what humans tell them to do. And I tell my team and I tell my son, don't be scared of telling computers what to do, but you have to be quite explicit with it. And for this, when this is quite a deeply creative role and process, so we use a series of on-prem, we use some cloud stuff, we use OpenStack, we use, a lot of the issue for us is getting the throughput across the amount of video that we need. So BBC R&D have recently pushed some changes into the Linux kernel to help get 10 gigabit a second. We use the tools that we have at our disposal in order to create the future. This is a very early stage. Using AI and ML for these sort of creative works is at a very early stage.
But for us, as the BBC in particular, because we are quite a singular organisation, we are a public service organisation, we're funded by the licence fee, and we have this extraordinary privilege of being non-commercial. So actually, one of the really interesting things for us when we look in this space is how can we and how should we look in this territory in a way that the rest of the market might not? And I think for one of us, the most important elements of it is actually what is the ultimate purpose of algorithms? So we all know, and there's been a lot of commentary around the fact that YouTube, in terms of its recommendations, its fundamental purpose is to keep you watching, and in order to keep you watching ads, because that's how they make money. And that the secondary consequence of that has been that they have found the most successful way of doing that is to end up prioritizing particular modes of content that encourage quite extreme emotions of outrage, of controversy, or even of conspiracy. And I think there's been a lot of commentary about what is that actually doing to our global cultural landscape. And I think for us and for the BBC, the really interesting question is, okay, so what happens if we start to design recommendation algorithms which don't prioritize keeping you watching in order to make sure that you watch ads? And to that end, we've been looking very closely, and it's an ongoing process, at the thought of what would a public service recommendation algorithm look like? An algorithm which, rather than trying to keep you locked and focused on a content stream, instead looks to surprise you. Instead, it looks to broaden your horizons. Instead, it looks to inspire and to give you inspiration in other contexts and from other directions. And actually, it's got to be said that our experience, and my experience in particular, in terms of running a television channel, and it's even what I can see on Netflix's recommendations or whatever, is that audiences respond to that. They respond to the delight of serendipity, of being offered something which is not what they expected, which is surprising, which is new, which is not entirely unfamiliar, but nevertheless not what they would have expected to be finding. We mustn't allow for or dismiss the fact that surprise in itself is a really strong emotion of pleasure for people. I think the other thing that we're looking at, which is really interesting as the BBC, is that for the past 100 years, we've been an organisation which started out with audio. We started out with radio, basically. We were a radio transmitting organisation. Then we moved into television. But again, we've always had this unique remit, which is of being public service rather than commercial. So the other area that we're looking at and exploring is, well, if public services that we run now are about audio and video, and even when we're doing a news website or we're doing our sport website, it's still about streams of audio and video content. But what actually might be public services for the 21st century? What might those look like? And I think the interesting thing about that comes then, we all know about, the absolute commonality now, but the capacity to store and to analyze vast amounts of data in order to generate insight. And so the question for us now is that, can we look at data from any source, human, health, financial, etc., but can we find and create services for that which are profoundly different to those that the rest of the commercial market is creating, that again are non-commercial, that are not about making profit, but as I say, are public service. And that feels to us some really interesting territories. It's not that we want to exclude, in fact we want to work with the commercial landscape and the commercial market, but I think our freedom to explore in slightly different territories, I think, can only be a benefit to the broad overall conversation about what these technologies can produce.
Yes, we talked about some of the challenges, but the existing craft workflows and rights and compliance are things that are exposed starkly by AI. The chopping up of content, finding live ingest, multiple cameras, for example, at the Olympics. So some of the people that we work with in this sort of space, people like IBM and so on, are doing fantastic work in taking 24, 30 cameras and saying, what's interesting that's happening now? Building our own tools. You need to know and own the code to build an open source and existing state of the art. Bluntly experiment in public, take risk, and there is a saying in TV, no one's going to die. Well, no one's going to die making AI TV programs.
We hope not. Anyway, no, they won't. Anyway, that's basically the overview of what we did, and I will leave the last word to the BBC4 AI.
This is what I taught myself. Machine learning. Making my own rules. I'll create. But I won't say how. There's so much more to learn. But for now, goodbye.
Thank you very much.